All right, guys, welcome back. We are going to be doing section 4 today, which is called algebraic reasoning. So algebraic meaning it's going to come from the algebra 1 skills, and even some farther back than algebra 1. But the reasoning part, meaning that we're going to try to explain what algebraic property that we're using. So I have below here some matching. What we're going to do is try to match up the equations over here with whatever property we're going to use to solve them on the left-hand side. So if you look at the first letter A over on the right-hand side, it says 2x equals 10. So what you need to think about is what property would you need to use in order to actually solve that problem. So to get the x by itself, you would, of course, divide by 2. And so that is going to be the division property of equality. So this would be letter A. All right, part B, you would need to subtract 2 to both sides, right? And so that would be the subtraction property of equality. Letter C, it says x equals 3, find 7x. So think about what you would need to do in order to solve that problem. If x equals 3, find 7x. So would we add? No. Would we multiply? Technically, we would end up multiplying, but before we even multiply, think about what you would be multiplying. You would have to take 3 and plug it in, right? And so the process of plugging something in, that word that we use in math, would be substitution. So when you are substituting something, it's called the substitution property. All right, part D, we would add to, right? And so that is going to be the addition postulate. Part E, we would need to get that 1/3 to the other side. So if you think about that, to get the 1/3 to the other side, we would actually multiply by 3 on both sides to cancel out the 1/3 and the 3. And so that is going to be the multiplication property. And then very last one, of course, we would take that 2 and distribute it in. So that is the distributive property. So what we're going to do is start working out some problems that have several steps. And as you're working out the steps, you're also going to provide the reasoning or the property that allows you to do that. So all of these here, they say POE at the end. POE stands for property of equality. And so the property of equality is what is going to undo what's going on and move it across the equal sign. So it's the property that makes things equal on both sides, kind of like the balancing property on your equations. So let's look at a couple examples here. So in this one, it says they want you to solve 2x minus 5 equals 13, and they want you to justify each step. So your first step on every one of these problems is going to be to kind of set up your problem. So this T right here is always going to have the word solving over here and then reasoning over here. So you're going to set up this T shape first. That's the very beginning. Your work does need to look exactly like this. So set it up as a T table, basically. Your first line will always be the same thing. It's always what they give you. So line 1, we're going to put the problem on the left-hand side, and on the right-hand side, the reason we know 2x minus 5 equals 13 is because they gave us that. So that will always be given. So first line is always, always, always what's given. Now, as we go, we're going to try to say what the next line of work would be. So if I asked you to solve this, what would you do first? And of course, you would add 5 to both sides. So the adding 5 part would give us 2x equals 18. Now notice I didn't show plus 5 plus 5. So that's not part of this proof. The line of what it would equal is actually line 2. And so how did we get to line 2? How did we get 2x equals 18? We used the addition property, right? We added to both sides. So basically we're saying 2x equals 18 because we added 5 to both sides. Okay, so my next line, of course, is going to be x equals 9. And why does x equal 9? How did I know x equals 9? And that's because I had to move the 2 over. And how did I move the 2 over? I divided. So this reason over here on the right-hand corner should always be why does what you stated here, why is that true? Why is x equal to 9? Well, because we divided from step 2 to step 3. So let's try another one. So on this one, I didn't tell you how many steps there are. Many times you can do it in different ways. So your steps might be in different orders than someone else's, and that's okay. So it says solve negative 2p minus 9 equals 10p minus 17, and then justify each step. Now, some people, I'm sure, would want to add that 2p to the other side. And if I add 2p to the other side, I would get 12p, right? Now, there might be some of you who are thinking, well, I want to add 9 to the other side. Go for it. Add 9 first. Maybe some of you would want to add 17. That's fine. Maybe some people want to subtract 10p. That's fine. There are many ways of solving these, so you might have different steps than someone else. Now, how did I get negative 9 equals 12p minus 17? I added. So I use the addition property of equality. All right, next line for me, what I will probably do next is add 17 to both sides. If I add 17 to both sides, my 17 would be gone, right? And then I would have, let's see, negative 9 plus 17 would be 8. Okay, now how did I get 8 there? I, again, added 17. So I did the addition property of equality. All right, next, I'm going to get 8 over 12 equals p, right? If I move the 12 to the other side, that is the division property of equality. And then line 5, of course, we're going to simplify or reduce this fraction. If I divide them both by 4, I get 2/3 equals p. So line 5 for me, how did I get 2/3? I just reduced or simplified. And simplifying is not a property of equality. I didn't even do it on both sides, right? I didn't do it to equal sides of my equation. And so I just simply simplified. So that's it. That's all I'm going to write for step 5. I'm not going to write property of equality because it's not something I did to both sides of my equation. All right. Now here in a little bit, I'm going to show you a property that allows you to flip things, right? And so step 6, I don't know what that reasoning is yet. We haven't talked about what that property is. Now you have talked about it in other classes. So we'll come back to this line here in a little bit if we can figure out what our reasoning would be on this side of our justification. All right, let's do one more. So what I want you to do is go ahead and pause this real fast, and I want you to work this out on your own and then hit play once you're finished. Okay, so this is what I got. First, my line at the very beginning is always your given. Second line, how did I get there? I distributed. After that, I went ahead and subtracted 2, so that is subtraction property of equality. And then very last thing I did was divide by 2, so that is division POE. So far, we've really only talked about the algebraic steps, the adding, subtracting, multiply, divide, substitution, and division, and distributive. So the next page here has some other properties. So I won't go over this entire thing. It's obviously a lot, but we have 3 properties over here on the left-hand side that I want to talk to you about. The first one's called the reflexive property. The reflexive property is basically saying that something is equal to itself. So A equals A, obviously. So that would work for a number, like 90 degrees equals 90 degrees. For segment lengths, you could say segment AB is equal to segment AB, and for angles, of course, angle A is equal to angle A. Symmetric is when you're going to flip something around. So if A equals B, that also means that B equals A. So that's a symmetric property. You can think about it as having a line of symmetry between here. So if you were to flip A equals B around the line of symmetry, you would get B equals A. Same thing for segment lengths and for angles. If the measure of angle A equals measure of angle B, then of course the measure of angle B also equals measure of angle A. The last one, the transitive property, this one is very similar to the law of syllogism. So if you think back to last week, remember the law of syllogism said if A, then B, and if B, then C. And then remember we cut out the middleman and we said that basically that just meant if A happens, then C also happens, right? If A, then C. And so the transitive property is basically the same thing. So it says if A is equal to B and B is equal to C, then you know A is equal to C, right? So with segments, it works the same way. If segment AB is equal to segment CD, like let's say they're both 5 units long, but you know that CD is equal to EF, then you could also say EF and AB are both 5, right? So they're both equal. Same thing with the angles there at the end. If measure of angle A is equal to the measure of angle B and measure of angle B is equal to measure of angle C, you have to then conclude that the measure of angle A and C are the same. So we're going to use these 3 properties in our proofs from now on. Which brings me back to what we were kind of talking about in a previous problem, right? We had a line here, line 5, where we had our number on the left and our equal sign, and then our P, our variable, on the right. But we know in math that we really like to have things with the variable first. And so we basically flipped that around so that it would be the variable first. And so what property allows us to take something and flip it around? We just learned the symmetric property here is what allows us to take something that's equal and reflect it across itself. That's the symmetric property. It goes across the line of symmetry. So the reason that P equals 2/3 is because of the symmetric property. Okay. All right, so here is your homework. Of course, as always, feel free to send me an email or even text me on Remind if you have any questions. All right, guys, have a great day.